Imagine for a moment that you could shrink down to a size so tiny, the world as you know it starts to transform into something entirely alien. A place where normal rules seem to go on holiday, and you find yourself surrounded by the quirkiest phenomena the universe can offer. Welcome, my friend, to the realm of quantum physics, where sci-fi-like concepts such as going through walls find a home in reality. Together, we're going on a mesmerizing tour of this enigmatic quantum world. It's a world where particles sway in a mesmerizing dance of ambiguity, pushing the boundaries of the conceivable to the extraordinary. So buckle up, as we plunge headfirst into the heart of quantum physics, where nothing is as you'd expect. Quantum physics is the oddball of the scientific family, a branch that centers its gaze on the most minuscule particles in the universe, like atoms and electrons. It's a different species from the everyday physics we're used to because it obeys peculiar rules at this teeny-weeny scale. In this wonderland-like quantum realm, particles play the most fascinating game of hide-and-seek, existing in multiple states simultaneously. Consider an electron, for instance. It can cheekily exist in two places or spin in two directions all at once. Imagine flipping a coin that could show both heads and tails until you dare to sneak a peek at it. And then there's quantum entanglement, a mind-boggling phenomenon where two or more particles become so intricately linked that they can no longer function independently. Regardless of the distance between them, a shift in one particle's state instantaneously influences the other. This peculiar bond enables them to communicate at a speed that makes light seem tortoise-like. This cosmic telepathy openly flouts the principles of classical physics and our day-to-day experiences, where objects maintain their independence and can't magically influence each other across vast expanses of space. Despite its mystery, quantum entanglement has stood the test of numerous scientific experiments, and while it remains a cornerstone of quantum theory, its underpinning mechanism is still a hot topic for debate. Quantum entanglement thrusts us into a deep contemplation about the fabric of reality. It points to a universe more interconnected than we could ever fathom, challenging our comprehension of space and time. This peculiar phenomenon continues to both fascinate and bewilder scientists and curious minds alike, marking it as one of quantum physics' most enthralling aspects. Within this microworld, particles can adopt a dual persona, masquerading as both waves and particles. This peculiar duality results in peculiar behaviors like creating interference patterns. Here, we're also forced to accept an element of the unknown. The more we strive to measure one property of a particle, the less we understand about another. This inherent ambiguity is simply part of life in the quantum realm. Perhaps the most whimsical trait of this realm is the ability of particles to penetrate barriers that, according to classical physics, should be impassable. Imagine particles with superhero-like abilities, phasing through walls like spectral entities. Despite its often mind-boggling concepts, quantum physics holds the potential to drive stunning advancements in fields such as computing and communication, making its mysteries ever more compelling. Let's turn our attention now to quantum computing, a promising and intricate field that uses quantum mechanics to process calculations. In simple English, let me unravel it for you. Everyday computers, like the one you're probably using right now, operate with bits. A bit can either be a 0 or a 1, symbolizing two potential states. It's akin to a light switch, it's either off or on. These humble bits form the backbone of all information processing in a standard computer. Quantum computers, however, operate with quantum bits, or qubits. Unlike their traditional counterparts, qubits can exist in multiple states at once, courtesy of a property known as superposition. This is like having a switch that can be both off and on at the same time. To grasp this, imagine a coin resting in your palm. In a classic scenario, it's either heads or tails. But in the quantum realm, the coin can exist as both heads and tails simultaneously until you take a look. The other star of the quantum computing show is entanglement. When qubits are entangled, a change in one qubit immediately impacts the other, regardless of the distance between them. This magical link enables quantum computers to process information simultaneously, making certain calculations exponentially faster than classical computers. So, quantum computing is all about harnessing these unique quantum traits to perform complex calculations rapidly and efficiently. It is especially useful for solving problems that classical computers find extremely challenging or impossible to solve within a reasonable timeframe. However, building and operating quantum computers is no walk in the park. They require advanced technologies and specialized conditions to preserve the qubits' delicate quantum properties and prevent them from losing coherence. For example, qubits need isolation from their surroundings to avert unwanted interactions that could disrupt their superposition. The might of quantum computers stems from their ability to run quantum algorithms designed to exploit superposition and entanglement. An algorithm like Shear's can factor large numbers exponentially faster than any known classical algorithm, posing a potential risk to modern cryptographic systems. Despite the promise, quantum computing is still in its infancy, and numerous challenges need overcoming. One key hurdle is quantum decoherence, where qubits lose their quantum states due to environmental interactions. Scientists are exploring error correction techniques and quantum error correction codes to overcome these issues and build more reliable quantum computers. While still a work in progress, the potential of quantum computing is immense. As it develops, it has the power to revolutionize how we tackle problems in fields such as cryptography, drug discovery, optimization, and more. The journey into the quantum realm is not just about unveiling the universe's secrets but also about pushing the boundaries of what technology can achieve. So, stick with us as we delve deeper into this fascinating world.